record. All right, good morning for pre-calculus. We are on our final exam review question here. So honestly, I confess that a lot of teaching you guys math and making you take it is so that we can tell our jokes to you and that you'll get them. Okay. So this is a math joke. So a mathematician enters a bar and orders a beer. Second mathematician opens the same bar and orders half a beer. Just let's assume that beers are infinitely divisible for the people who are bartenders or know anything about this. It's a math problem, so it's set up to be a fun problem, not to argue whether or not a bartender will pour you half a beer, a fourth of a beer, and so on. So with that aside, okay. This should have been a part B. What's the limit? Because that's the punchline of the joke. Okay. I used to tell one about rational functions, and if we'd have something like x minus 3 over x squared minus 9, we'd have x minus 3, x minus 3, x plus 3. People would cancel the x minus 3's and note that you'd have a whole, but you'd also have an asymptote. So the whole idea for this problem was whether or not you could tell the difference between an asymptote and a hole in a graph. And then I stopped telling that because nobody got the joke. So, or my timing is terrible because that's equally that's more probable. But it's a different error. So here we go. We're ordering a beer, and then a half a beer, and then a quarter of a beer, and then an eighth of a beer, and then a 16th of a beer, and so on. Okay, so the idea here is a geometric series because the distance, right, the distance between each of these two values, each of these, there's a common ratio between each of the values. If I added something, it wouldn't work. So we need a common ratio to get it. And all I'm doing is multiplying by a half, aren't I? Right, so our common ratio is 1/2. I'm like, well, how do you tell that? Well, what's 1/8 divided by 1/4, right? What's 1/8 divided by 1/4? I could also ask what's 1/16 divided by 1/8. And do you remember how you're supposed to do division by fractions? Right, this is 1/8 divided by 1/4, and that's 1/8 times 4/1, which is 4/8 or 1/2. Same thing, it doesn't matter which one you pick, they will always give you the same common ratio. If they don't, it's not a geometric series, and you can't do the problem with the tools that you have. You have to hope for something else. So of course I set it up as a geometric series so that you could solve it. But this would be 1/16 divided by 1/8, which is the same as 1/16 times 8/1, which is 8/16, which is a half. So of course you're going to get a half every time. Okay. So we usually call this R. We say R is a half. Okay. Now if R is bigger than 1, you have to hope that they're going to stop somewhere. Okay, because if they don't stop, you can't actually add this up. It gets to be too big. It's what they call diverges. Okay, I think there's a Futurama where Bender shrinks himself and makes 2 of them, and then gets to be bigger than the universe or something, and pretty much takes up all the mass in the universe. So that's what happens when you don't have R as less than half. Okay, so right. So the next thing we're going to do is we're going to note, geometric series. So this is A plus AR plus AR squared plus AR cubed plus ... right? And we know that this is going to add up to something because our R is small, right? It's less than 1. So what we're going to do here is we're going to multiply our sum, right? We are going to add these up, all right? We'll assume that they add up to something, or we're going to stop. We'll stop. Okay. So if I multiply r by the sum here, because we've got a finite number of things to add up, we could do that. Even if there's 1,000 of them, we could add them up. Okay, this is going to be AR plus AR squared, right? Because it's multiplying R by each of these terms. So R times A is AR. R times AR is AR squared. R times AR squared, AR cubed. What do we get when we have AR to the n minus 1 and I multiply that by R? Well, we end up with AR to the n plus, and then this one, right, the last term is AR to the n plus 1. Okay, so that's what we have. Now what I'm going to do is I'm going to take S minus RS. I'm going to take the top one minus the bottom one. And because these add up to something, we're allowed to do that. If you have a series, this happens quite a bit. If you have a series that does not converge to a particular sum, you can't do this. You can't treat them like numbers. So just as an aside, this is a pretty famous one. 1 minus 1 plus 1 minus 1 plus 1 minus 1. This doesn't add up to anything. You can't treat this like it does. Okay, so that would be wrong. You can't do that. Okay, because it's 0 or 1, 0 or 1, or 1 plus 0 plus 0 plus 0. So you see the difficulty while we have this. But going back to the problem we can do, and the problem that you're going to be doing on your final, all right? So if we go ahead and subtract, right, we have S minus RS, S minus RS, S minus RS, all the way out, right, until we get to this one. So here, we're going to have SA minus AR to the n plus 1. Okay, now what I'm going to do is, notice S is common to both of these. So we have S 1 minus R is equal to A 1 minus R n plus 1. Okay, all divided by 1 minus R. So we have S is equal to A 1 minus R to the n plus 1 divided by 1 minus R. Okay, what did I ask you for? I asked you for, like, what is this? How many, expressed as a fraction, of beers will the bartender have poured once the 16th mathematician has entered the bar? Okay, so remember the first one ordered 1. Okay, so we have 1 minus R to the n plus 1, so that's going to be, oh, sorry, let's go ahead and plug some numbers in here. So we have 1/2 raised to the 17th. Okay, I think I put 9th or something. I changed it, but then I didn't update the problem because that's going to be difficult to deal with. And then that's 1 minus 1/2. What is 1 minus 1/2? It's 1/2. Okay, so we have 1 minus 1 over 2 raised to the 17th. Now, I know my powers of 2 up to 10, because being somebody who grew up in the 80s, they said, oh, computers are going to be very powerful. You're going to need to know all your powers of 2s. And they were wrong. Okay, so this is 1 minus 1 over, because the 2 gets raised to the 17th, okay? And what was that? That was 131,072. 131,072 all over half. Okay, so what I'm going to say here is that 1 can be cleverly written as 131,072, 131,072,000, 131,072. That's the number I'm looking for. If you put the word "and" in there, that signifies that's where the decimal place is supposed to be. So, I mean, nobody will ever catch you on that, but that's what it is. So when people say 131,072, it's like, oh, you meant this. No, that's not what you meant. So it's 131,072. That's the proper way to say it. Okay, so here we have it. We have 131,072. Oh, minus 1, so 71 over 131,072. So 131,072 divided by half, which is the same thing, right, as times 2. So decimal wise, okay, just to give you an idea. So we'll take our 31,071 times 2 to get our proper answer of 262,000. What do we have here? 142 divided by 131,072. So there we have that. And then just to give you an approximation of what this is, I'll beg my pardon there. So we're going to divide this by 131,072. So 1.999, a couple of nines here. Okay. And then 847. Okay. So real close to 2. Not quite. If. Okay. So just bear with me a little bit here. Okay. If we go back up here, we go up to our 1 minus 1/2 raised to the n plus 1 over 1/2. If I let this get really, really big, okay, like n is 1,000, okay, n is 10,000, n is 100,000, okay, we get this to be really, really, really big. What's happening to this fraction? Okay, what's happening to this fraction is getting smaller and smaller and smaller and smaller and smaller. So if you take something like 1 minus 0.5 raised to the, I'm just going to draw a couple of zeros here, okay, that. There's too small. There's not enough decimal places to hold this number and take 1 minus it. So this disappears to almost nothing. Okay. So really we just have 1 over 1/2, and that's equal to 2. All right. So if you have an infinite number of mathematicians ordering smaller and smaller and smaller fractions of beer, that's going to converge, and it converges to 2. So, you know, our joke is mathematician orders a bar, or enters a bar and orders a beer. Second one enters the bar and orders half a beer. Third one orders 1/4 of a beer, and so on and so on and so on. The bartender says, okay, you guys have to know your limit, and pours out 2 beers. Okay, so again, another terrible joke, but now you get it. Or at least now you know how to arrive at this answer. So you can tell that joke at Thanksgiving and amaze all of your friends and relatives and draw the ire from everybody at the table. Okay, so that's our last problem there. And I wish you all good luck on the final. And if you have questions on that, let me know. And there we are. Okay, thank you.